In this video, we're going to look at the probability of compound events. That means two or more events happening in a row. And we're going to be talking about events that are independent of each other. Independent means that the first event does not affect the second event. So for example, if I flip a coin, what I get the first time I flip, whether it's heads or tails, is not going to have any effect on what I flip the second time. If I'm pulling, let's say, marbles out of a bag, as long as I put the marble back, it would be an independent event. But if I were to pull the marble out and not replace it, now the bag is different. So that would not be an independent event. So we want to make sure that each event is independent. It doesn't change based on what previously happened. And so when we're looking at independent events, we're going to find the probability of each event, and then we're going to multiply their probabilities together. So what are the chances that the first event occurs? What are the chances that the second event occurs? And then we're going to multiply them together. So let's look at some examples. So we want to find the probability of rolling a 2 and flipping heads. So event 1 is rolling our die. And we know that when we roll a die, it's possible to get a 1, a 2, a 3, a 4, a 5, or a 6. So we have one chance of getting a 2 out of 6 different possibilities. So we have a 1 out of 6 chance of getting the 2 that we desire. For event 2, we are flipping a coin, and we know that when we flip a coin, we can get heads or we can get tails. So we have a 1 out of 2 chance of flipping our coin and it landing on heads. So to find the probability of the two events occurring together, we would multiply these together. So we would have 1 out of 6 times 1 out of 2, and that would give us a 1 out of 12 chance of getting both a 2 and a heads. Okay, this time we're going to look at 3 events. Same process, we're just going to have 3 things happening. So we want the probability of flipping heads 3 times in a row. So the first time we flip our coin, we have a 1 out of 2 chance of getting heads. The second time we flip our coin, we have a 1 out of 2 chance of getting heads. And the third time we flip our coin, we have a 1 out of 2 chance of getting heads. So we're going to multiply these together. 1 out of 2 times 1 out of 2 would be 1 out of 4 times another 1 out of 2. We'd have a 1 out of 8 chance of flipping 3 heads in a row. Okay, continuing on, we're going to look at a little bit more complicated of a situation. Now we're going to be looking at drawing cards out of a deck. So a couple things that we need to know about a deck. A deck has 52 cards. And so we want to know the probability of drawing a face card. So if you're not familiar with a deck of cards, there are 4 suits, and each suit has a jack, a king, and a queen. So each suit has 3 face cards, and there are 4 total suits. So we have a 4 times 3 would give us a 12 out of 52 chance of drawing a face card. If we wanted to just make the numbers a little bit easier, we could reduce these. These are both even, so we could divide them both really by 2 or by 4. Sometimes having it in simplest form makes it a little bit easier, so let's divide both of these by 4. So our chance of drawing a face card is 3 out of 13. Then we want to look at our second event. Our second event, we're going to put the card back so that it stays independent, is we want to draw an ace. In drawing an ace, there's 4 aces in a deck. So we have a 4 out of 52. Again, it's really helpful to simplify this. So if I divide by 4, I get a 1 out of 13 chance. So the probability that these two events occur in a row would be 3 out of 13 times 1 out of 13. So 3 out of 169. So very unlikely that I'm going to get a face card and an ace.